Okay, final page here, number 17. A coach travels from Dronston to Lusco, and we've got this travel graph. Work out the average speed of the coach in kilometres per hour for the first 10 minutes of the journey. Okay, so if we want speed from a distance time graph, we're going to do distance divided by time, just as we would in using speed, distance, time. In other words, we want the gradient of this line here. Okay, so the distance covered in that amount of time was 9 kilometres. The time that took was 10 minutes. Now the problem is it wants this in kilometres per hour, not minute. So I don't want to use minutes, I want to use hours. What is 10 minutes in terms of an hour? Well, there are 6 10 minutes in an hour, so that's 1/6 of an hour. So speed is 9 divided by 1/6. Okay, and you can do that on your calculator, or you could move the 6 up here. Any denominators on a fraction which is being divided by can come up and multiply by the numerator. So that's 9 times 6, 54. Okay. The other way to do that question is to think it's travelling 9 kilometres in 10 minutes and then sort of scale that up to an hour. So if you times that by 6, there will be 6 of those 9 kilometres in 1 hour. Okay. The coach stops in Lusco for 15 minutes. The coach then returns to Dronston at constant speed. Show this information on the travel graph. So 15 minutes would take us up to 45, and then 42 kilometres an hour is the speed. We've got to travel 21 kilometres, so we want the time that takes. 21 divided by 42. Hopefully you can see that this number is half of this one, so this would be 0.5, or half an hour. So that's 30 minutes. So from 45, another 30 minutes would take us up to 75 minutes in total. There we go. Okay. On to proportion, probably the hardest topic in this test. Okay, A is directly proportional to B, so we can write that like this, a fish symbol, B. It's not really a fish symbol. We can immediately change that to an equals K. Now, K is the constant of proportionality. A and B may change, but K won't. So as soon as we found K, then we can just put it back into this equation. We'll use A and B again, and then we'll have an equation we can use for any subsequent parts to the question. So to find what K is, we're going to use this given information here. So we're going to substitute in A is 90 and B is 20, and I'm going to put 20 first because that's the convention with algebra. You put your number in front of any unknown letters. So K, I can work out from this, is 90 divided by 20, or 9 over 2, which is 4.5. So now that I know K, I can go back to this general equation here and just swap K for 4.5, and there we go. And I'm going to use that in part B to calculate the value of A when B is 7. So all I'm doing is using this, substituting B as 7, and that's a multiplication there. And that would give me 31.5. Okay, we've got another of those style of questions here. So P is inversely proportional to T. So the difference with inverse proportion is that we write 1 over. That's really it, to be honest. We then change that proportion symbol to an equals K, and we can put the K in place of the 1. And we do exactly the same as above. To find K, we substitute in our values that we've been given. So P is 12 when T is 4. Come up here and use this space. If I want to work out what K is now, I need to get rid of this 4, so I need to times by 4. That would give me 48 there. So K is 48. So my overall equation linking P and T is P equals 48 over T. Find the value of P when T is 6. So 48 over 6 is 8. And finally, match the graphs of y against x represent 4 different types of proportionality. Match each type of proportionality in the table to the correct graph. Okay, well, if y is directly proportional to x, that would mean that we could write an equation that looks like this: y equals something times x. And thinking back to when we plotted graphs, linear graphs will look like this: y equals something x plus something else. Okay, and that's very similar to what we've got here. We don't have a plus something else, but we saw that those types of graphs where you haven't got a constant at the end just meant that the constant was 0. In other words, they went through 0. This was the y-intercept, this number at the end, if you remember. So they went through 0 on the y-axis, and they had a gradient of m, okay, or k in this case, a steepness of k. So this is a linear graph. It's graph B, starts at the origin, has a steepness of whatever k is. Okay, y is proportional to x squared means we could write an equation that looks like this: y equals k x squared. Okay, and if you remember the y equals x squared graph, that gives us a parabola shape. In other words, one that looks like that. And changing the number in front of the x squared just made that graph narrower. If we increase that number, it made it narrow. What's actually happening there is that all the values were being stretched upwards, to be honest. Okay, now we don't have any graphs that look like that, but that's because we're just looking in the first quadrant of these graphs. In other words, this would be if our graph was like that. Okay, so we're just looking at this section here. I'm going to rub that out because that's getting a bit busy. Oops. No, it's not going to let me. No, never mind. Okay, so this, the only one that matches that sort of shape is D. And finally, sorry, not finally, we've got this one next. Y is proportional to the square root of x. So y equals something times the square root of x. Okay, we're going to come back to that one actually. Let's deal with this one next. So y is proportional to 1 over x. So our equation would be y equals something divided by x. And it was only, must be in the last topic or the one before, where we plotted graphs like this. Y equals something over x are called reciprocal graphs. And if we had all 4 quadrants to our grid there, it would make a graph which looks like that, with asymptotes, points where it will get closer and closer to the axis but never actually touch it. And again, we're just looking at the first quadrant, which seems to match graph C here. So by process of elimination, the square root of x must be a. Okay, thanks for watching.